Hello, and welcome to CFD Research Corporation's Tech Talk on a fast-running simulation framework for advanced performance analysis of carbon-carbon structures. CFD Research Corporation is a small business headquartered in Huntsville, Alabama, with approximately 260 employees, 70% of which hold advanced degrees. For over 35 years, CFD Research has leveraged its unique expertise, passion, and experience to develop quality solutions for organizations across government and industry, with major customers in Army, Air Force, Navy, NASA, and MDA. Our core capabilities include modeling and simulation, software development, and test and evaluation. CFD Research has commercialized and transitioned multiple technologies including both hardware and software capabilities, has spun out 6 companies, and holds 80 patents. Our DoD SBIR Commercialization Achievement Index puts us in the top 10% of companies nationwide. Among the diverse range of capabilities, the Aerospace and Defense Solutions Division specializes in modeling and simulation capability research and development for a wide range of applications, including thermostructural modeling of carbon-carbon materials in extreme environments. The Navy faces a challenge when developing thermal protection systems for new and existing weapon systems. Namely, how to choose from among a variety of possible carbon-carbon architectures and processing methods that can result in different properties. The current build and see method is expensive and time-consuming due to high costs of materials and experiments. State-of-the-art physics-based digital simulations can also take a significant amount of time due to the tendency to evaluate large numbers of configurations or environments that a material may encounter. As a result, the Navy has expressed an interest in a fast-running model appropriate for rapid design iteration and trade space optimization. The requirement aims to address uncertainty in the effects of material architecture and manufacturing decisions on vehicle performance and survivability through rapid analysis of the performance before conducting higher fidelity simulations or more costly experiments. Variation in manufacturing processes of carbon-carbon materials can result in inconsistent material quality and bulk material properties that govern the performance of the material in their operational use case. The uncertainty in the ability to predict the material properties ultimately leads to uncertainty in the end vehicle performance. Fabrication and testing of enough materials to assess sensitivity of performance to process variability is not feasible, due to cost and time requirements. For the same reason, full physics modeling and simulation of variable flight trajectories for every discrete set of unique material properties is also not a practical solution due to the time required on the order of hours for each individual trajectory to execute models. The intent of this tool is to improve upon current analysis chains by providing a framework to generate a very efficient model that, once trained, can be used to quickly determine performance variation due to changes in bulk material properties. To meet this need, CFD Research is developing a set of models that can rapidly assess the viability of proposed material architectures. The framework will generate a machine learning surrogate model to deliver an assessment of the survivability of a vehicle with novel material properties. The simplicity, speed, and reliability of the model will enable agile analysis and development of new protection systems. The core surrogate model, once trained, can rapidly evaluate the structural response of composite materials on complex geometries. After pairing with CFD's verified aerothermal modeling software, capable of running at near real-time speeds, an untested material architecture could be evaluated across a full trajectory in minutes. The rapid modeling capability could enable easy architecture optimization and vehicle risk assessment that current models would struggle to provide in reasonable timeframes. The model is currently under development, with initial proof-of-concept surrogates finishing training and data generation underway. Full surrogate capabilities are projected to come online in the first quarter of 2025, with a verified model and toolchain in the third quarter of that year. Validation campaigns leveraging experimental testing on manufactured TPS materials will be executed in subsequent contracts or Phase 2 option period in the event of additional awards. Key features and benefits are listed in the table shown. The first primary advantage is the use of already trusted, verified, and validated core software components for generating the model training data. These codes are currently in use by several DoD and industry customers, leading to smoother transition and adoption into existing workflows. The second core advantage of the material model over existing toolchains is its speed. Surrogate models can evaluate novel conditions in a fraction of the time when compared to conventional tool chains and can significantly reduce the complexity of a modeling system. In addition, the primary product deliverable will include a software package to automate the process of data generation for training specific customer use cases, given some initial baseline model inputs. Numerous programs for developing, building, and fielding vehicles with composite thermal protection systems are underway across the Department of Defense. Given that the rapid modeling solution being developed in this project could enable significant improvements in design optimization and risk assessment as a function of possible material changes, whether due to obsolescence, process variation, or swap-C improvements. CFD research sees broad applicability to many of these programs. The core capability of the software could easily inform decision-making across the design, fabrication, and quality control phases of vehicle production. The tools being designed to integrate well with existing material analysis and design tools used by CFD Research's government and industry partners. This new modeling capability could be leveraged by government and industry teams with varieties of resources and needs. CFD Research is experienced in on-site teaming for aerothermal design projects and could use a similar model to deliver tailored model generation, analysis, and consultation services to Department of Defense customers. For projects willing to undertake training and analysis in-house, the software package could be licensed with support from CFD. For projects that need expanded capabilities beyond the existing software, a research and development partnership could be used to add features and provide system-specific support. The CFD Research Corporation is excited to bring this new capability to DoD project. To learn more about our modeling and simulation work, visit cfdresearch.com or contact us directly.